Alright, I had to force. Oh, stream because I can't. Okay. Hello, everybody. Yeah, let's go. Oh, wait. Uh, where is it? Aha, found it. Alright, we're gonna study. And here's a cool trick I found. Look at this. If I mute myself, now it goes away. See? It's over here too. See? Yeah. Okay, that's cool. Now I would know when I'm muted because it's visual. See? Alright. Let's get back to where oh yeah, he has one too. Why did I never open? Actually, no, his one you have to pay money, right? Yep, $99 per month. Yeah, I need my money. Okay, we could do some geometry. We're almost done with the geometry, and then we can watch the SAT. Oh yeah, let's also open this. So if like I hear anything, oh no. I'm so bad at focusing, bro. Even in my free time. Okay. You know what? Wait. Let me stare at the wall for like 10 minutes. Um, where's my 10-minute timer? Found it. Alright, first let me be sure that it actually makes a sound. Wait. Huh? Wait. Do, 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 do. Do, 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 do. Do, 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 do. Um, hmm. Um, how do I show this? Select this. No. Let's delete that. Also, how do I show the timer? It's not even here. Okay, okay, so we can't use this timer. We can use an, oh no, what did I do? We can use another timer, which is the 10 timer. Wait, got it. Okay. Wait, okay, here's it. Okay, so let's see. Will it make a sound? I guess that works. That 0, 10, 0, 0. Alright. That did not feel like 10 minutes, but okay. Yo. Well, okay, nice. Alright, let's watch some geometry. Let's, oh, that's right stuff. Alright, so, where were we? I remember doing this, but let's do it again.
Okay, so
There's most calculate. Okay. I you know what, let's do this problem again. Give me the pencil. Alright. L is 18. Okay, so L equals 18. W is 9 and H is 12. Okay. What is the surface area and square units of the pyramid? Surface area means all the outside part. So all the outside part of a square or like triangle. So like length times width. So length times width, which is 162. So 162 plus now we need to find this part and this part. When we find this part, we can times it by 2 to get that one and this one also. So you are not allowed to do length times height and then times 1/2 because this height and this line are two different stuff. So you have to do here. So if we make this triangle, so the triangle, if we make the triangle flat, let's say like this. Okay, you know what? Let's use the big one. Yeah, if we make the triangle flat, sorry, going over your head. And here's the thing that's in the middle. If we made it flat, that the bottom one will be L, which is 18, and H is 12, and this part we don't know what this part, and this part is, oh my god, this is like illusion. Oh, the illusion. This is this part. Okay, so we need to find the hypothesis, but we also have to remember that the line height is in the middle. So technically this is in the middle, meaning we only need half of this thing, which is the same thing as half of here. So L divided by 2 is 9. So from here to here is 9. Also, sorry for drawing on your face, but yeah. So 12 and 9. Now we need to find the hypotenuse, which is 12 square plus 9 square equal hypotenuse square. Oh, I already defined what h is. Okay, wait. Okay, so b squared. So b is 15, meaning this is 15. Meaning a line from here to here is 15. Meaning times width is 9. So, I mean, I could also do that. So it's 135. Alright, now let's move this. Let's just have, you know what, let's do width. Okay. Now we have to do the opposite. So it's width of the opposite side. We need to find from here to all the way here. Okay. Because we need to find from here to all the way here, we do the same thing. So we make this flat. Oh wait, no. Wait, what? Wait. Yeah, that's correct. So, now, oh yeah, we make the triangle from here now. So from the W. So, bam, bam, bam. The whole bottom part is W. Let's not make it confusing as it already is, because you can't visualize it that much. Boom. This is W. Um, the height is still the same. The height is 12, I think. Yeah, 12. W is 9, so like 9. But what's W divided by 2? Because we're trying to find half of W, which is 4.5. So from here to here is 4.5. So so let's find the hypotenuse. So let's just make this 4.5. We get 12 point blah 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 blah. So what we do is B times not length. Wait. Yeah, we're trying to find that part. So B times L, which gives us blah 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 blah. So let's make this C. So we do. Wait, did I forget? Oh my god, I forgot to write the other one. Okay, so this was L. This was L. Which makes it so one of these is L. 4.5. Okay, yeah, so this becomes 9, which gives us 15. And so times B is the down part, yeah. Okay, so this becomes W. So we get this. Oh my goodness. Why did I define this as C? Okay, we got the W, right? Yeah. Okay, let's go until I defined it by C. Yeah. Destroy that. Actually, no, you know what? Let's define that by C. Boom. And let's get another one which also has B times L. Now remove the L with the W and put the L here. And over here, remove that with 9, which gives you 15. I am so dumb. Okay, over here. Yes, that's good. Duplicate that also, because this is a B. Let's remove that with, let's say V. Oh my god, they rhyme. Boom, V. But we don't know what V is. Oh, wait. No. V is not that. V is... I'm making this complicated. I'm making this so complicated. V is 9, which gives us 15, which gives us this, which gives us... Oh my goodness. Which makes us a C plus times W, which is like maybe G. And the answer is that. Yeah. Oh, wait. I forgot to divide it by 2. Oh my goodness. Boom. That's the answer. Let me see. Did he get that? Bloop, 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 bloop. Oh wait.
This question should be
Huh? What did I do?
simpler in terms of like the amount of steps it takes. Okay, but hopefully like, you can use the same on it for 1/2 because it's a triangle. We'll multiply it by 2 because there's 2 of them.
Oh, I forgot to chew it. And yeah, you
Okay, so now we should have the volume. Sorry, the surface area. Okay, the answer is 527.6 or 0.7. So actually, if you didn't know, on the SAT, you can only type in 5 characters. For numerical response questions where there's no multiple choice and you have to type in the number yourself, it only accepts 5 characters max. You can actually round this number to 7 if you want to. It doesn't matter. You don't have to round it, but it can only accept 5 characters. So basically, it won't even let you type in a 6th character. By the way, a negative sign does not count as a character. So if you put a negative sign, I guess you could type in 6 characters if you want to. But there's no negative, so that doesn't matter. Okay, you just type in 5 characters. Negative sign doesn't count as a character. The decimal point does count as a character. So that's 1, 2, 3, 4, 5. You can round this last one if you want to. It'll accept both ways. It doesn't matter. Okay, but it won't even let you type anymore after you type in 5. So you just like keep on typing until you can't type anymore, and then it'll accept that answer. Okay. So the answer for this one was 527.6 or 0.7, depending on if you rounded it or not. Okay. Now let's do another question. This question should be simpler in terms of like the amount of steps it takes. Okay, but hopefully like, you can use the same strategy of just, okay, let me get like an idea of what the formula is, and then just like try to like piece together what the formula is, and then idea. Okay, but hopefully like, you can use
a cylinder can. Wait, look at my... Oh no! Bruh, I pressed 5 and I forgot that in YouTube if you like press 5, it changes the video's timeline. Alright, yes, look at my beautiful face. While I open up, what am I opening up? Oh yeah, SFT math formula sheet. How about that do? Oh yeah, sheet. Okay, copy image link. Oh yeah, my laptop is screaming for mercy. Okay, we're back. Oh my goodness, OBS is using like 51 CPU? Why's it using so much CPU? Okay, 19% CPU. Wait. Let me like open task manager. Who's using more CPUs? OBS not using CPU. Wait, OBS is using more CPU, but Microsoft Edge is using more memory. Oh yeah, when I open the task manager, everyone cools down. Never mind, OBS is going high at 25%. Microsoft is using somehow less than 1% of CPU, but they're using a lot of memory. Alrighty. Okay, oh wait, let me turn the quality down. Oh wait, this is down. Let's do like sweet. Yeah, it's readable. Yeah. I'm sorry for turning the quality down to 380. Okay. A cylinder can contain cylinder. So a cylinder is this. Cylinder can containing piece of fruits is filled to the top with syrup before being sealed. The base of the can has an area of 75 centimeters cm2, and the height of the can is 10. So 10, so 750 of syrup. Uh oh. If 1/110 to the third of syrup is needed to fill the can to the top, which of the following is the closest total volume of the piece of fruits in the tank? So isn't that 750 minus 110, which is 640, which is C.
This question should be simpler in terms of like the amount of steps it takes. Okay, but hopefully like, you can use the same strategy of just okay, let me get like an idea of what the formula is, and then just like try to like piece together what the formula is, and then you can get the answer. Hopefully, we'll just do this question. It'll make more sense as we do more of these practice questions. Okay, hopefully you pause the video and try solving it. This says a cylindrical can. Okay, there's no diagram, so actually I have to draw it out. Fine, okay. So a cylindrical can containing pieces of fruit is filled to the top with syrup before being sealed. Okay, so basically there's like a cylinder, and the only thing inside the cylinder is fruit and syrup. Okay, so there's a cylinder, there's pieces of fruit. I'm just gonna put dots as fruit. So there's a bunch of fruit, and there's a bunch of syrup inside this. And there's just fruit and syrup. The base of the can has an area of 75 centimeters squared. So we're given the base. Yeah, this is a great example of the fact that you can't just like blindly memorize these formulas. You have to understand where it comes from, because it just says the base. It doesn't tell us the radius at all. So if you don't have the radius, like how are you supposed to get this? Right, but it tells us the base, and we realize, oh, pi r squared is the base. So this is the base times the height. And the base is going to be the thing that you want. So the same idea here. So I want you to recognize that pattern in case you see something like that. That way you don't have to spend time thinking about how to solve the question. If you see this type of pattern where it's like, oh, unneeded stuff, and what's left is the stuff that I want, then you could just use this pattern right away. But this is 640 is the answer. Oh, we didn't even need to like round or anything. It's literally this was the answer right away. Okay, yeah. The answer here was 640, then C. Okay, let's talk about more patterns. So the next pattern is inscribed shapes. And I want you to pause the video and see if you would be able to figure out how to solve this.
Inscribed shapes. In the figure, the triangle EFZ is inscribed. He taught me this. Inscribed means like it touching the max length it can go. In circle, C, which has a radius of 10. So the circle has a radius, that's a very bad line, of 10. If the length of HG is 16, okay, right. HG is 16, and the circle's radius is 10. Oh my goodness. From here, yes, perfect. To here is 10. What is the area of EFG? EFG. So it's a triangle. Blah, 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 blah. So because we know the radius is 10, this is a diameter, I think they call it. So it's 10 and 10 here. I'm making it so it's 20. But that's not what they want. What is the area of? So 20 plus 16. Oh no, not plus 16, and then on. Wait, no, that's it. 20 plus 16. Oh wait, but it's a triangle. We're not trying to find the red triangle. So divide 2, which is 160. I think I did something wrong. What is the area of EFG? EFG. Bam. So isn't it? It's a triangle, so we just need height and length. So 16 times 10. So 16 times 10 divided by 2. I did something wrong. I don't know what I did wrong. Okay, from here to here is 10, right? The radius is 10. Meaning from here to here, the radius, I mean, the length is 20 because it's touching the circle. Alright, so we want to find EFG, which is EFG, this, and red triangle. So to find EFG, you have to times length times height. Wait, does it say it? Yeah, length times width, and then divided by 2, like that. So because it's half of a square, so we know that 16 is HG, 16, meaning the top part is also 16 because it's a red triangle. We don't know what this part is. Oh yeah, we don't know what this part is. So we do a simple 16 square plus square equals 20 square, and this is 12, meaning 12 times 16 times, nope, yep, and then take all of this divided by 2 gives us 96. Now what did I do before? Did I do 20 times 16? I think so, which is wrong. It's 96.
This question, at least like have an idea of how you could. Okay, hopefully you like read the question and you tried your best to like figure out how to solve this, because it's going to make this way more memorable. Okay, there's actually a really good strategy for inscribed shapes. Okay, so in the figure, rectangle EFG, so it's just this rectangle, right, is inscribed in a circle C. So basically what inscribed means is just it's as big as it can be inside that other shape. Right? It doesn't even have to be a rectangle inside a circle. It could be the other way around. Let's say there's a square and there's like a circle inside the square. But inscribed shapes is basically meaning they're touching at like the max. Like this circle cannot be any bigger inside the shape. Same thing for this. This rectangle can't be any bigger. At least like proportionally, it can't be any bigger. Right? And it's like all the edges of the rectangle are touching the circle. That's what inscribed means. It could be like a triangle inside a circle. It could be like any shape inside. It could be 3D, like there's a cube inside of a sphere, things like that. Okay. But the general strategy for inscribed shapes is you have to find the common length between the two shapes. So What I mean by that is, what length can we work with between the two shapes? And that's, if we can find what the common length is, there's going to be one length, at least one, that's going to be in common between the two shapes, and we can use that length to convert between the two shapes. Okay, so in this case, which has a radius of 10, okay, so we'll find, well, you can do, because we're trying to find the area of this. Okay, next let's talk about inscribed, or the,
He got the answer, which is 96.
so C you would pick, and then that should be the answer. Right, hopefully that makes sense. Inscribed shapes, just find a common length between the two shapes. Okay, because they're inscribed, it should be pretty easy. Just look at the points that are that are touching, and then try to like see if you can like draw common lengths. And if you're doing a circle, try drawing the radii or the diameter and see if that works. And it shows the shape that's inscribed, or like it's being inscribed in. Okay. Next, let's talk about proving triangle questions. And you notice these questions only show up in the hard second module. They don't show up at all in the first module. And I doubt it's going to show up in the easy second module if you get the easy second module. Because these questions are hard. It's just supposed to be hard. They're actually pretty simple if you know what you're doing. But like they're kind of like a niche thing that you just have to know what to do. If you don't know it, then you're going to get the question wrong. But if you do know it, it's pretty simple. Okay, so the proving triangles, the main thing is proving congruency and proving similarity. So I'll go over this. So first of all, what's the difference between congruency, so like proving something, two triangles are congruent to each other, and two triangles are similar to each other? Now, congruent just means they're the exact same shape. Like literally, the sides are the same, the angles are the same, every single thing about the shapes are the same. Okay, congruent doesn't just apply to triangles, but I've only seen proving triangle questions on the SAT. But it could be like congruent, like rectangles or something. I don't know. I've never seen that though. But you get the idea. It's congruent just means they're the same. And then similar, which we talked about earlier, is just one of them is bigger than the other one. Okay, they have the same angle, like the proportions are the same, but one of them is just bigger than the other one. That's similarity. Okay, so those are the differences between congruency and similarity. It's really important that you know, because a lot of people get those confused. Okay, congruency is they're the same, similar is one of them is bigger than the other one, but everything else is the same. Like the angles are the same and everything. Okay. Now, there's different, I guess, ways you can use to prove if something's congruent, and different ways you can use to prove if something's similar. Let's actually go over similar triangles first, because we already went over that earlier in this video, and we could just do a quick refresher. But there's two ways to prove similar triangles. There's only two, by the way. Okay? First way is proving that the angles are the same. Okay, all the corresponding angles are the same. So basically, if you have a triangle, you have another triangle, and let's say one of the triangles angles equals 30, 60, and 90, and the other triangle also equals 30, 60, and 90, like the angles, then we know those triangles are similar to each other because all the angles are the same. And actually, you just need to know two angles that have to be the same. Right? Because if we know two angles of a triangle, let's say we know one triangle is 30, 60, and we don't know what this one is. Like we don't know what the last angle is for this triangle, and we know the other one is 30 and 60, and we don't know what the last one is. This is enough to prove similarity. Because if you know two angles, you can get the third one. Like 180 minus 30 minus 60, that's going to equal 90, obviously. So we can solve for the other ones. As long as two angles are matching, two separate angles in the triangles are matching, then we know those two triangles are similar. So that's one thing, proving angles are the same. And the other way to prove that triangles are similar is proving that the side lengths of the triangles are proportional to each other. Now, this is different from angles. We can't just do two. We have to do all three of them, actually. So let's just show you. So let's say we know one of the sides of a triangle is 2, one of them is 3, one of them is, I guess, let's see, that's not possible. I'll show you why later on, because you're learning why that's not possible. I think this is probably possible. Yeah, okay, so 2, 3, and 4. Okay, those are the sides of a triangle. Is that? Yeah, I think that's okay. And then that means and then another triangle was 4, 6, and these are the sides of the triangle again. Okay, so we know one triangle has the side lengths 2, 3, and 4, and the other one has 4, 6, and 8. You notice this one, like if you look at this triangle, there's always a side length that's 2 greater than the one before, the smaller triangle. Right? So that means it's always like the scale factor of 2, and it's consistent between all the sides. So that means that these triangles are similar. Now, if you only knew one, that's not enough. That's not enough. You need to know all of them. Because you can have two triangles. Because you can have a triangle, and like we know these side lengths, but this third length can be drastically different. It doesn't have to be the exact same triangle. Like, it could be this side length, or we can take the exact same lengths, like this length and this length, and make them, like, for example, this and this. And like this third length would be drastically different. Right? It's like imagine this is the same as this. So basically I'm just showing you that just knowing two of the sides of a triangle doesn't automatically determine what the third one is. Because we don't know, that's only for right triangles where you can use Pythagorean theorem to get the third one. This is just regular triangles. So just knowing two of the sides isn't enough. You need all three of the sides to actually prove that, oh, all of these are proportional. So it's much easier to prove with angles. But sometimes the question like forces you to prove using the sides and show that they're all proportional too. But that's how you prove similarity. Okay, so there are two ways. Okay, don't get us confused with congruent angles, congruent triangles. My bad. It's only for similar triangles where you can use all the angles are the same, or I guess two of the angles are the same, and or all the sides are proportional to each other. So actually, let's solve this question. See if you can do this. This is on the harder side, by the way. So read really carefully and try your best. So pause this video, see if you can do this.
Oh wait, this is a question. Um. Okay, so in triangle LMN, so the triangle is LMN, and RST. Okay, let's draw a smaller RST. RST. Angle L and R each have 960. So this is 60. 60. Ln equals 10. And RT is 30. Which additional piece of information is significant to prove the sum that belongs to
AAA side goes side. So, but I would highly recommend you draw it out. It's just worth the ABC. See if you can redo a practice question. So try this.
okay, I'm back. Where are we? Alright, so Ln is 10 and RT is 30. That's okay, ST. Okay. 10. Okay, so bigger and so on. So 10, 3. Oh, I mean, obviously I knew the okay. So 7, which is MT. Oh, MN times 3 is solid. Wait, what? 7 times 3 is 21. I didn't know that. So NM, which is here, and ST, MN and ST. This could work. The measurement of angle M and S are 70 and 60. Are 70 and 60 respectfully. Very respectfully. The measurement of angles M and T, wait, M and S should work, not M and T, right? Wait, no, they're not the same. Okay, are 70 and 50 respectfully. Alright, wait, let's test another thing. If I do 180 minus 60 minus 70, and then again minus 60, that doesn't work, and that works. So C is out. So it could either be B or D. D would most likely work because M is here and T is here. Huh. I mean, it could most likely work. That will prove that they're similar. So D is more likely to be the answer than B.
Let's solve this question. See if you can do this. This is on the harder side, by the way. So read really carefully and try your best. So pause this video, see if you can do this. In triangles LMN and RST, angles L and R each have measured 60. So let me draw this out real quick. So LMN. I'm just drawing regular triangles because it doesn't say that they're right triangles. This is R. That's a really small R. ST. Okay, we know L and R. So I'm not gonna like actually right now. This is what I usually like to do. I just like symbolizing to myself. Okay, these are the same, right? And LN 10 or T30. LN. I know they're not the same length, and this notation means they're the same length, but I'm just like doing this just to show. Okay, we know these. And by the way, I'm thinking this isn't enough because it doesn't tell us any other stuff about the side length. We do know that there's like a scale factor of 3 here, right? Like this is 3 times greater than this. The problem is we need all the side lengths to be like that. Like this has to be 2 times greater than this. This has to be 2 times greater than this. So we need like 2 more pairs of side lengths. But I don't see that. I only see like 1 more pair. So right away we eliminate A because this should be 3 times greater than this one. This is the same. That's not good. Okay, we need to be consistent. Right? Since this is 3 times greater, we need to have the same proportion between the sides. This one is 3 times greater, but it's like NN and ST. That's not good enough. We need all 3 of them. Okay, and just knowing 2 of them doesn't automatically mean that the third one is proportional. So we can eliminate B. So it has to be C or D. Now let's read C. The measure of angle M and S are 70, so it says this. No, they have to be the same. These are corresponding angles, right? If we drew so these have to be the same. And it says the difference, so that's wrong. It might be that like S is supposed to be this angle. We can work it out. So I'll show you what I mean. So like the measure of angles N and T are 70 and 50. So if we draw this out again, because it went away, it said M and T. Right, so this is L, M, N. And this is RST. So it told us this was 50, right? And it told us M was 70. And we know these are 60. Okay. So this is actually like a pretty common trick they like to use. This is actually good enough. The reason why is because we know these 2 angles, we can solve for this one. What is 180 minus 70 minus 60? 70 plus 60 is 130. And then 180 minus 130 is 50, right? So that means this angle is 50. And this angle is 50. So that's actually enough. So the fact that it gave us 2 separate angles. So like it gave us this angle, and then it gave us another angle that wasn't corresponding to that angle. But that's fine. We can still use the information that it did give us to prove that, oh, there's at least 2 angles that are the same for these. Okay, hopefully that makes sense. And like this one might have worked, but the problem is like 180 minus 70 minus 60 does not equal 60, it equals 50. So like even if S was like this angle at the bottom here, and like it would actually like I messed up the drawing and it should have been like these two angles should have been flipped around or something, it still wouldn't have mattered because that's not 50. Like it should be 50. In this case, it is 50. And by the way, like you don't need to, whichever order it says the triangle in, just draw that in the same order. It's like L, M, N. So like this just means the first angle should be L, second angle should be M, the third angle should be N, and so the first angle should be I, second angle should be S, third angle should be T. So as long as you draw it out like that, like L, M, and then you put like exactly, so the middle angle like is at the same spot, those are the corresponding angles. Like the whichever order the angle appears, it's going to be, so like the M is going to be corresponding to T, S is corresponding to M. So just the tips for when you draw the triangles. I've never seen otherwise where it was like, oh, actually M is corresponding with T. I've never seen this. This is like the middle angle is going to be corresponding, the leftmost angle is going to be corresponding, and the lastmost angle. So you just draw it out like that. Okay. Now let's talk about proving congruency, which is, I don't know if it's harder, but it's like new stuff you have to learn, right? You kind of already knew similar triangles. Now let's go over congruent triangles. Now, congruency, the only way you can prove congruency is one of these four. And maybe you think, oh, there's 4 things I have to memorize, like what is SAS? It probably should seem familiar to you. It's probably been a while since your geometry days when you were doing this stuff. But you're like high school. Usually geometry is like your first or second year, and you're probably like third years. So I guess it's not as like familiar, but this should like seem somewhat familiar because most of you are taking geometry by now. Okay, but really, what does this mean? Like, and how do I memorize this? Because it's actually a really easy way and a fun way to memorize this. Okay, so basically, if you think about every single combination of SAS, there's like 2 letters, A and S, and there's like three spots for them. Okay, SAS. So we're for 3 letters, and you can only use S and A. How many combinations are there? Okay, there's SAS, ASA, AAS, SSS. There's also AAA, right? And also AS. AS, excuse my language, but ASS. Okay, these are the 2.
Yeah, my teeth. Why am I pausing?
Right? And also AS. AS, excuse my language, but ASS. Okay, these are the 2. And I'm not counting about like if you like flip something like SAA. I'm not counting about that because it's going to be the same. Like on a triangle. By the way, A and S stands for side and angle, in case you forgot. So angle, side, like angle and a side. Right. So like if I do like angle, side, that's the same thing as side, angle. It's just like depending on like which direction you're looking at it from. So it doesn't matter. I'll show you what I mean later on. Okay, but it's just no like this. Flipping it doesn't matter. Okay, so the other combinations, though, AAA proves similarity. Okay, it doesn't prove congruency, so that's out. So just remember, okay, AAA proves similarity, and ASS, or you can think of it as SSA. All I remember is that the SAT is PG, so there can't be curse words on the SAT. So that makes it really easy because, okay, there can't be curse words, so AS is out, and similar triangles is out, so there's no AAA because you're trying to prove congruency. So all that's left is just these 4. So that's a really easy way to memorize this. Just like think about all the combinations of A and S for 3 letters, and then just eliminate the curse word and eliminate similar triangles, which is AAA, and then what's left is just these 4. That's a really easy.
Why do I have announce?
Way to memorize this. Okay. Now, what do I mean by like SAS? So basically, it's saying the side, the angle right next to that side, the side right next to that angle. Okay, this is SAS. And it's basically saying, okay, if I have 2 triangles, and I know, okay, this side is equal to this side, and then the angle next to, one of the angles next to that side is the same, and then one of the sides next to that angle is the same, then, and these are, so this is the same as this one, okay, this angle is the same as that angle, and this side is the same as that side, then that's enough to prove that these triangles are congruent, meaning they're the exact same triangle. So if you see this combination where like you have 2 triangles, and then
wait, give me a second. Give me like a quick second. Quick second. Oh, okay. Nice. I wish so Obama back. Let's do this. Oh yeah. Like this one.
there's sides and there's angles and there's a side right next to that angle that are the same for the 2 triangles. If you go between them, then that's these two triangles are the exact same triangle. They're congruent. Okay, same thing. So let me just draw the triangles again. I kind of hate how it disappears, but I'm dealing with it. So angle, side, angle, angle, side, angle. Like this works too. It could also be like angle, side, angle. It doesn't matter. But as long as it's like there's a side right next to that angle and the angle right next to the side, I'm dealing with it. So angle, side, angle, angle, side, angle. Like this works too. It could also be like angle, side, angle. It doesn't matter. But as long as it's like there's a side right next to that angle and the angle right next to the side, then that's fine. Okay, and angle S, you just like the angle. So this angle, the angle right next to that, it doesn't matter. Like this one, and the side right next to that angle, like angle S. Right, if you choose this side, this would be angle side angle now. That won't work because angle side. That would work. Okay, well, side is all the sides are the same. Okay, hopefully that makes sense. Let's do a practice question. If that didn't make sense, then I think it will make sense after we do a practice question. So try this for yourself. So pause the video.
Okay. Where are we? In triangle ABC, yes, ABCD. In triangle ABC, so ABC, ABC, that look like a 6, and DEF, D, E, and F. That's a very bad F. Bam. Angle B and E each have measure 27. Angle B and E. Let's like put a line to tell ourselves they're both the same. How am I gonna write 27? You know what? Got an idea. Yeah, boy. 27. Nice. And angle C and F, each have a measure of 41 degrees. Angle C and F. What? 41? Yeah, 41. Which additional piece of information is significant to determine whether triangle ABC is congruent to triangle BEF, DEF, the measurement of angle A. Oh, I just realized if there's two angles that are similar to each other, then the third one is also similar to each other, because blank 180 minus this 2 and these two would give you the same this. Yeah. The measurement of angle A, the length dot, no additional dot. Let's say the measurement of angle A. Yes, if we get angle A, we will get angle D. But
Leo, see if you can solve this. Okay, hopefully you try solving it. So in triangles ABC, let's draw the triangles. I know it can be annoying, but I would highly recommend you draw it out. It's just worth the extra few seconds to guarantee you didn't mess up any angles in your head or anything like that. Just a public service announcement.
Wait, give me a second. I heard like fireworks. Let me see. Let me see if it's like actually fireworks. La 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 la. Why would some people put fireworks at daytime? Like, what's the point? Huh? Oh, alright, let's go back. Well, oh my god. I think it was 500 milliseconds. Was it not changing? Okay, nice. Whoa, well, 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 well. I should really stop playing with this. You know what, let's make it 300 milliseconds. That's 200 milliseconds. Nice. I hear the, not the gunshot. You know what? Wait, give me a second. I really want to see this. Where is it? Where's the boom boom? I want to see the boom boom. Oh, it's balloons. They're popping balloons. I thought it was gunshots. I mean, fireworks. Family friendly, but like, okay, it was balloons. They're popping balloons. I think it's someone got married. Congrats. And yeah. Let's go back to our thing. Where are we? Um, yeah, most likely, 100%.
For you? Okay. So here's a triangle. A, B, C, and then D. And by the way, I have seen a question where D was like no additional information necessary. It was the correct answer. So don't just eliminate that, by the way.
Oh.
Yeah. Okay. Anyways, so we have this angles B and E. So we know these are the same. I just like showing that they're the same. Okay. B and E are 27. C and F each have measures. So C and F. So by the way, we have an angle and an angle. So all that's left, remember the four angle, I'm thinking angle side angle, like angle side angle would work. ASA would work. So here's ASA. The other combinations are angle side. Right, we can do angle, angle. If we know like this side with this side, that's enough. Or like this side, if it says that this side is the same as this side, or that this side is the same as this side, or that this side is the same as this, like any side in general, if it says that, then that's enough to prove congruency. Angle, angle, angle won't work because that's similarity, right? So like this angle, this wouldn't work because that's similarity. I think that's all the combinations out of the four, because the other ones are side, side, side. That won't work. So we have two angles, right? The other one is side, angle, side. We have two angles already. We don't. Then we would need like two sides. We need like this side and this side, or like this side and this side. That's so we need like two sides and an angle in between them. And I don't think that's going to work, right? It just give us two angles. We just probably just need one of the sides. If you look at the answer choices, yeah, angle doesn't work. That's only one. It's not even like two. It's not like,
okay, I want to make a poly video. Oh, it's obviously not A. C, B, C, B, C, and E, F, E, F. Yep, it's
this angle the same. It's not even that. Side angle, that's not even like two sides. Oh, they're making it super easy. Okay, the length of the side BC. So BC, yeah, and yes, that's angle side angle, right? Angle side angle. There's two angles. We know these angles are the same. This side is the same, and this angle is the same. Bam, that's angle side angle. So we have a way to prove that they're congruent angle side angle because it's one of the four that proves congruency. So C would work. Because I would prove that these two triangles are congruent. Angle side angle now. That won't work because angle. I know it could be annoying, but our angles B and E. So we know these are the same. I just like showing that they're the same. Okay, B and E are 27. C and F each have measures. So C and F. So by the way, we have an angle and an angle. So all that's left, remember the four angle. I'm thinking angle side angle, like angle side angle would work. ASA would work. So here's ASA. The other combinations are angle side. Right, we can do angle, angle. If we know like this side with this side, that's enough. Or like this side, if it says that this side is the same as this side, or that this side is the same as this side, or that this side is the same as this, like any side in general, if it says that, then that's enough to prove congruency. Angle, angle, angle won't work because that's similarity, right? So like this angle, this wouldn't work because that's similarity. I think that's all the combinations out of the four, because the other ones are side, side, side. That won't work. So we have two angles, right? The other one is side, angle, side. We have two angles already. We don't. Then we would need like two sides. We need like this side and this side, or like this side and this side. That's so we need like two sides and an angle in between them. And I don't think that's going to work, right? It just give us two angles. We just probably just need one of the sides. If you look at the answer choices, yeah, angle doesn't work. That's only one. It's not even like two. It's not like this angle the same. It's not even that. Side angle, that's not even like two sides. Oh, they're making it super easy. Okay, the length of the side BC. Yeah, and yes, that's angle side angle, right? Angle side angle. There's two angles. We know these angles are the same. This side is the same, and this angle is the same. Bam, that's angle side angle. So we have a way to prove that they're congruent angle side angle because it's one of the four that proves congruency. So C would work because I would prove that these two triangles are congruent. Okay. And finally, so we went over proving similarity, proving congruency, but now let's go over how to like actually prove it's a triangle. Because like there's actually like rules for it. There can only be this many this length of sides for a triangle. That makes sense. Like the third side of this triangle can't be greater or less than this length. And this is called the triangle inequality theorem. Now, you actually don't need to know this theorem because for every single, at least digital SAT question I've seen, I remember back in the paper SAT, I think you had to know this, but I'm pretty sure you don't need to know this now. Like you generally don't, but you do need to know the trick that they test you on involving this thing. So here's like a good question to simplify that. So actually, I just wanted to try this because it's better if you like make the mistake and then you'll learn from your mistakes. So I wanted to try this and like get the question wrong, and then that way I can tell you, oh, this is actually how you do it. It's
Okay, I can. Okay, so it's like 1 in 4 chances. Think about it. Either if I get it wrong, I can still get it right by getting it wrong in 1/4 chances, or have a 70% chance of getting it wrong if I guess, and a bigger chance of getting wrong if I don't guess. So yeah, let's do it. Okay, a triangle. Yes, we love triangle. Red triangle is the big one. Okay, red triangle. So triangle. Yes, that's a big pointy triangle. A triangle integer theorem states that the sum, of any two sides, any two sides of a triangle must be greater than the length of the third side. Oh yeah, so like the side of this, if let's say if this is 3 and this is 4, this has to be 5 because 3 plus 4 has to be greater than. Oh wait, it's only with right triangles, right? Yeah, it's with right triangles. The hypotenuse has to be bigger than both of this, like 3 and 4. It has to be bigger than both of this, but if you add both of this together, these two numbers have to be greater than the hypotenuse. So that's the theorem. Of any two sides of a triangle must be greater than the length of the third side. If a triangle, you mean right triangle, if a triangle has sides length of 7 and 10, okay, 7 and 10, which is a representation of possible angle x of the third side of the triangle. Yeah, x has to be small. This is right. X has to be, wait, must be greater than the third side. Yeah, so x has to be smaller than 17, which is both of them. This is wrong. I mean, there's no actual. Wait, no, there is a limit. It cannot be. It has to be greater than 7 and 10. So this is wrong. This to be greater than 7 and 10. So x is more than 3, or x. No, it's a.
gonna stay in your brain much longer. So now that I said that though, you probably won't make the mistake. See if you can like beat me and like not make the mistake.
Yeah,
so pause the video, see if you can solve this. Okay, let me solve this question now. The triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the length of a third side. So that's just the triangle inequality theorem. I'm going to explain this as we read on. So if a triangle has side lengths of 7 and 10, which inequality represents the possible lengths of x, of the third side of the triangle? So if we have a triangle and we are told that this is 7 and this is 10, what can be this length? And it's not like this length could be like 1,000, right? Like that's not possible. Like if you think about it, like even if I stretch these two sides to the very maximum, like I just like stretch, it's pretty much a straight line at this point. I can't connect like this 1,000 length side. It's going to go off the screen. I can't connect the endpoints of the endpoints of this line, yes, to the rest of the triangle. It's not possible. So there has to be a limit to what the third side can be. And if most of you, at least watching this video, probably thought like 7, it has to be a number less than 17. Because 7 plus 10, like any two sides of the triangle, right? So 7 must be greater than the length of those sides. So basically it's saying if I add up two sides of the triangle, so 7 plus 10, that must be greater than the third length. So this third length can't be 17 or greater. It has to be a number less than 17. And then you picked A. Like, that's be a number less than 17. However, that's actually not right. Okay, you are right on the fact that this side length has to be a number less than 17. However, what if the side length was 1? Would that still satisfy the triangle inequality theorem? Because remember, it says any two sides of
Wait, so the answer's not A?
a triangle. It doesn't satisfy the triangle inequality theorem because remember, it says any two sides of a triangle. It doesn't say that it has to be specifically these two sides, like 7 and 10. It could be that this side length and this side, like 7 and 10. It could be that it's this side length to this side. If you add these two side lengths, 7 plus 1, that equals 8, which is less than 10. So it can't be 1, actually. So there actually is a minimum too, not just a maximum, but a minimum side length for this triangle. Okay, so what is that minimum? I think you probably already like got the answer by now. But so if I like what I had to figure out, so like 10 is obviously the maximum. So if this isn't the maximum side length, then that must mean 10 is the maximum, like the largest side length on this triangle. So that must mean that this side length has
My hypotenuse. Let's see.
to be like 7 plus this side length has to be greater than 10. Okay, so 7 plus 3 would equal 10. So that means this third side length has to be a number greater than 3 as well. Okay, 7 and because it has to be these two side lengths sum has to be greater than 10. So we can't do this. So it has to be like some number greater than 3. So maybe 4. Like 4 plus 7 be 11. That's fine. And that's greater than 10. So the correct answer to this question is actually C. And congrats for the people that did figure this out and got it correct the first time, because this is a really hard question. It's pretty much a trick question. It's really hard to recognize that because most people would just assume it's A immediately. And maybe they forget to check out the answer choices, or they forget to consider, oh, might be the lowest thing. But now you know. Now that you've experienced this trick, you won't fall for it during the actual test. So if you see something to do with triangle inequality theorem, like these two side lengths must be greater than the third length, like that, then you know, okay, there's also the greatest length, also the smallest length it could be. And they count for the minimum and the maximum side that this third length could be, following this theorem.
Okay, let's try to do this. Obviously, I got it out. Okay, now let's understand from mistakes. Okay, so this was the triangle. Because it wasn't a right triangle, so this could have been 7 and this could have been 10. And now we were like, oh yeah, so this has to be the smaller number, 10 is the highest. But no, because let's say if this was a 1, then 1 plus 7 will not be over 10. If this is 4, 4 plus 7, 7, 8, 9, 10, 11. That would work. Because it switches. If you make this 17, let's say this is 17, then 10 plus 7 has to go, and then they realize it won't work. Cannot go above 7, cannot be 0 or 1. Wait, can I like draw this here? So that's lower than 17. Oh yeah, it does work. Boom. Yeah, my brain was like, oh yeah, so this is the biggest number. But let's say this x could have been a smaller number. Like, let's say it was like 3. So then this becomes the biggest number. So 7 plus 3, 7, 8, 9, 10 won't work. Um, hmm. But 4 plus 7, 8, 10, 11 works. Hmm. So what about 16? That's more than 7. Oh wait, now this is the biggest number. But then 10 plus 7 goes above it. Ah, okay, nice.
Side that this derivative could be following this field. Last and definitely the least is circle characteristics questions. These like pretty much never appear at all for some reason. They used to appear a ton on the paper SAT. I don't know why on digital SAT they pretty much never appear now. But there are a lot of circle characteristics questions, at least what I like to call circle characteristics questions, on the question bank by College Board. So it's not like they're not going to test this. They could definitely test you on this. So I would know this. It's just they don't show up on the actual test for some reason, like at all. But I think it's helpful to learn. There's only been one sort of characteristic question, at least what I'm about to go over, one of these questions in like the past 12, 13, I think, around official tests. And that's why there's only in the first module. There's like a pretty easy question, actually. It's never been like a really hard one. But it used to be all over the place in the paper SAT. Yeah. Okay. I don't know, but I'll just go over this just in case it does show up and you know this. So, by the way, when I say circle characteristics, I'm not talking about circle equations. Circle equations actually are pretty common. They show up all the time. That might be like what they're listening to. They want to do more circle equation questions for some reason. But I'm talking about like normal circle questions that you can't solve with Desmos. So there's no like equation of a circle. There's no unit circle thing going on. You can solve this with Desmos, which I have like the Desmos guide for it. And I also have a separate video just for unit circles that you can watch on my YouTube channel if you haven't done that already. I'm talking about circle characteristics just for like the questions, like the normal non-Desmos questions that you can't really solve with Desmos to start to end. You actually have to know like a bit of geometry to solve the question. For these questions, I break it down into, I guess, like two sections. There's arc length and sector area, as well as just like random characteristics you have to know. Okay, so it's just, I guess, two different areas. Let's go over arc length and sector area first, which I think a lot of people get this overcomplicated with. It's actually pretty simple if you just know this formula, which is basically the central angle of a circle. Which, so that's just like the middle angle, right? Central angle is just the angle at the center. The central angle. So the angle at the center. Right, it's pretty self-explanatory. So the central angle over the angle 360. Degrees.
Let's go.
Right, so the entire angles. If you don't know, it's also in the reference sheet. It really tells you here. Right, the number of degrees of arc in a circle is 360. the number of degrees in radians is 2 pi. But basically, the entire angle of a circle adds up to 360 degrees. Okay, so that's where the 360 comes from. So the central angle over the entire angle of the circle is equal to the arc length over the circumference. So it's equal to, so this over like all this entire angle is equal to this over this entire circumference. I know it's not like this entire circumference of the circle, and it's also equal to the sector area. So like this area thing over this entire area. Okay, so if you can't tell already, like these arc-length sector area questions have to do with like circles looking like pizza pies. So if you see like a pizza slice type of thing, this is a, you have to use this formula pretty much. And I think this, you don't even need to memorize this formula because I think it just makes logical sense. Right? Like if I have, it makes sense that the fraction of this over this is the exact same as this over like the circumference of the circle. It's the exact same as the area over the entire area of the circle. It doesn't make sense. It just looks like they're proportional to each other, right? Like you just imagine, like it should be like, I think it should just click that. Okay, that makes a lot of sense, right? Okay. You can memorize it if you want to. I don't think it's like, I just want you to understand, just to make it make sense to you. Okay, yeah.
Mm.
It's like looks proportional. Like draw them out, like just look at them, you should be able to tell. That makes sense. It's the angles on top of the entire circle angle, the length of the circle on top of the entire length of the circle, and the area of that circle, or a portion of the circle over the entire area of the circle. Like all of those are the same. If they're like within the same, I guess, pizza slice. Right? Like this angle and this arc and the area of this arc. Like it's the same, right? For like pizza slice, proportionally to the entire circle. Okay. I'm like going deep because I like want you to understand it. So that way you don't have to like waste the brain power to actually memorize it. I think it's much easier.
Huh? I have to go pray. Oh yeah. Let me just copy this. Why is it not going away? Alright. You know what? Just keep it. I will fix it. Oh yeah, I have to go pray now. Yeah, I will be back. Yeah.